Hello there, this is an Algebra 1 video. It is Chapter 8, Section 8, and today we are talking about differences of squares, and we have seen this earlier in the chapter, and so we are now going to basically work backwards. We learned how to factor these little guys already before, so this formula should look familiar to you. So I'm just going to go ahead and jump right in. When you have a difference of two squares, that's when you have a squared minus b squared, and whenever you want to factor a squared minus b squared, you get a minus b times a plus b. Now, the next two sections actually are going to be factoring techniques that will help if you recognize the pattern, but sometimes students won't necessarily recognize the pattern. I just want to remind you that if you don't recognize the pattern, you could always use the previous factoring method where you had the ax squared plus bx plus c, but the b value, the middle term, would be 0. So you think about when you get your numbers to work out here, you want the two diagonals to add up to 0 because it's missing the middle term. So, but at the same time, if you notice that it's missing the middle term, then figuratively speaking, it should be quite obvious to you that if it's missing the middle term, that this is the formula you want to use. So just so that you know that formula, that method will work in this case, as long as you keep in mind that the middle term is 0. But otherwise, what you want to do in this case is to factor using this formula. So in order for us to do that, we have to identify what a and b are, because you will see that we have a squared minus b squared. You have to have it in this form in order for you to be able to write it in this form. And so the first thing we want to do is identify what a and b are. So I'm going to go ahead and rewrite this guy. I know that 16 is a perfect square as well. It's 4 squared. So I'm going to write 4h quantity squared, which means 4 squared is 16 and then h squared. And I also know that 3 squared is 9, so I'm going to write over here 3a squared. And then over here I'm going to go ahead and do 11 squared minus 2b squared, because 2 squared is 4. And then c I'll leave for a later time. And so one of the first things that you want to do when you're doing this is to identify what a and b are. So in my case, a is going to be 4h. Over here, a is going to be 11. And then in this case, b is going to be 3a. Notice that I don't attach negative 3, it's just 3a. The minus is there, but it's already taken care of in the formula itself, so you don't want to attach negatives to it, it's just 3a. Over here, my b value is not going to be negative 2b, but just 2b. So once you have identified a and b, all that's left to do now is to actually write the answer out. And I'm going to go ahead and write that down here. We know we're going to get a minus b, so in this case, my a is 4h, and my b is 3a. So just like that, you have your answer, 4h minus 3a and 4h plus 3a. It doesn't matter if you put the plus and the minus, if you put plus here and minus there, that doesn't matter, but you have to have one of each. So there you go. And in the case of b, very similar. This time we'll do plus minus, just to be different. So you get 11 plus 2b and 11 minus 2b for part b. So it's not very hard if you identify what a and b are first. Now in part c, we're going to do that one a little differently, because first of all, you don't see that it's a difference of two squares. You don't have a squared minus b squared, you have g cubed. Also, you should recognize that 27 and 3 have a factor of 3 in common. So the first thing you're going to want to do in the case of part c is to actually factor out what is in common. So I'm going to take out a 3 and then take out a g, and I know that 9 times 3 is 27, and g squared times g is g cubed, and then 3g times 1 is 3g. So I get 9g squared minus 1. Now this is interesting because a lot of times students neglect to recognize that 1 could be 1 squared. 1 squared is also 1. So what you want to do in this case is when you write out your A and your B, you're going to have 3g squared for the 9g squared minus 1 squared, and then the 3g out here. So obviously the 3g is not going to be part of the formula, but what's inside these brackets is part of the formula. We know that A is going to equal 3g, and that B is going to equal 1. So to write our final answer, we're going to have the 3g, we'll have a plus and a minus. We have 3g plus 1 and 3g minus 1. And that will be our final. So sometimes you actually have to factor something out before you can actually apply the difference of two squares. So I hope that makes sense. So you're going to try these 4 examples, and then we're going to do some more with this. So basically now, again, you're still noticing that there's only 2 terms, so it doesn't have 3 terms. And typically we only use that factoring method that we learned in the previous lesson when you have 3 terms. So again, it should be, I wouldn't say it should be obvious, but you should kind of have at least some inkling that this might work if we have a difference of 2 squares because there's only 2 terms. But the problem is that you have it to the 4th power. Well, we can deal with that by rewriting the problem. So what I'm going to do is I'm going to write b squared squared minus 4 squared. In other words, we know that when we have a power raised to a power, that we multiply the exponents, and that becomes 2 times 2 is 4. So b squared squared is the same thing as b to the 4th, and then of course 16 is the same thing as 4 squared. In the case of the 625, and for part B, we know that 25 squared is 625. So we'll put 25 squared, and again, we're going to go x squared squared. When we do that, our A value is b squared. This is my A squared minus b squared. My B value is 4. Over here, my B value is x squared, and my A value is 25. So like before, we're going to take our formula, which says to do A squared minus b squared is going to become A minus b times A plus b, or A plus b times A minus b, either way. So in this case, A is b squared, and b is 4. In this case, b is x squared, and A is 25. So you get this, b squared minus 4 times b squared plus 4. And you might think that you're done, but you're actually not done. Because what happens here is that after you factored it the first time, now you are left with another difference of 2 squares. This is b squared minus 2 squared. Alright, so in that case, your A is going to be the b. So we'll do that again. So now for this guy, A equals b, and b equals 2, because you've got 2 squared. So you have A squared minus b squared. So now, for this factor here, we're actually going to get b minus 2 and b plus 2. So the b minus 2 times the b plus 2 takes care of this factor here. And then of course you don't want to forget that you still have the b squared plus 4 from before. And there is no sum of 2 squares formula. So this guy is just stays the same. But this would then be the complete factorization for part A. And so a similar thing is happening over here in part B, because again you've got 25 plus x squared, and that's just going to stay 25 plus x squared. But we also have another scenario where you have a squared minus b squared. So this time, a is 5, because you got 5 squared is 25, and b is x, because b squared is going to be x squared. So now we're going to put our a plus b and our a minus b. So again, the 25 minus x squared breaks down into these two factors, 5 plus x times 5 minus x, and of course 25 plus x squared from here stays the same, and this becomes your complete factorization for part B. So sometimes you have to do the formula twice, and that's basically what we've demonstrated for you in this example. So now I want you to try these, and then we're going to go to one more application of factoring before we get to solving. So here is our third example, and again, at least in part A, you might be thinking, okay, there's two terms, so I might try difference of two squares. But in part B, it's not actually obvious because you have 4 terms. So we're going to have to, sometimes you have to apply different techniques that you've learned previously, combined with the one for this lesson, so you can get the problem done. So in part A, one of the first things you want to do is to factor out anything they have in common. They both have an x variable, and both 5 and 45 are divisible by 5. So we're going to pull out the 5 and the x, and that's going to give us x to the 4th, because x to the 4th times 5x is 5x to the 5th, and then negative 9, because negative 9 times positive 5x is going to give you negative 45x. So now, as we look at our result, our resulting factorization, what's here in parentheses, the x to the 4th minus 9, looks vaguely like a difference of two squares. Of course, we have x to the 4th, and that's going to be an issue, so we want to write that as x squared squared, and then minus 9 is 3 squared, and then of course we don't want to forget that we still have the 5x out here. So in this case, our a value is x squared, and our b value is 3. So according to the formula, we're going to get a minus b and a plus b. And of course, you don't want to forget there's a 5x out here from before. And this time, when you look at the x squared minus 3, you're completely factored because 3 is not a perfect square. So you cannot break this down into another difference of two squares. So at this point, this is your final answer. 5x times x squared minus 3 times x squared plus 3. And then in part B, we have a similar scenario happening where we want to combine techniques. The first thing I noticed is that they all have 7 or 21, and we know that that 21 and 7 have a common factor, which is 7. So the first thing I'm going to do is to factor out the 7, which will leave me with x cubed plus 3x squared minus x minus 3. Okay, then I want to attempt to do a factoring by grouping. So I want to take these two terms at a time. And in the first set of two terms, I notice they both have an x squared. So I factor out the x squared, and that leaves me with x plus 3, because x squared times x is x cubed, and x squared times 3 is 3x squared. In the case of the next two terms, I'm going to factor out a negative 1, which will make this an x, because negative 1 times x is negative x, and make this a positive 3, because negative 1 times positive 3 is negative 3. So all that works, and then of course I still have the 7 out there. Now what I'm going to notice is that if I look at this as all one term and this as all one term, as we have in the past, we talked about factoring by grouping in the past, I'll notice that both of those circles have a common factor, and that common factor is x plus 3. They both have the x plus 3. So I'm going to take out the x plus 3, and what remains is the x squared minus the 1. And of course, the 7 needs to come down as well. Now you might think that you're done with the factoring, but again, I will caution you that you have a difference of 2 squares right here. This is the same thing as x squared minus 1 squared. So again, you want to take 7 times x plus 3. And this time your a value is x because you've got a squared, and your b value is 1 because 1 squared is 1. So I'm going to say x minus 1, x plus 1. And now I have completely factored part b. So again, just be careful. You want to try to combine techniques sometimes, and don't leave it with the perfect square in there at the end. So now you can try these little guys. And then we have our last example, which does require some factoring, but also solving. So it says here in the equation y equals x squared minus 9/16, which is a value of x when y equals 0. So you have these options, A, B, C, or D. So in order for us to figure that out, we actually have to solve this equation. So we're going to replace the y with the 0. So we're going to say 0 equals x squared minus 9/16. It's no surprise that even though it's a fraction, we know that 9 is a perfect square and 16 is a perfect square. So we could actually rewrite this as x squared minus 3/4 squared, because 3 squared is 9 and 4 squared is 16. And when we do that, we can say this could be a squared minus b squared with the fraction in it. So what we're going to do is we're going to use our factoring to write this out. So we're going to say a is going to equal x in this case, and our b value is going to be 3/4. So according to the formula, we get x minus 3/4 and x plus 3/4 all equal to 0. And we already learned before that when you have two factors here, you want to use a zero product property, which says that you can take each factor separately and solve it. So x minus 3/4 equals 0, and x plus 3/4 equals 0. And when you do that, in order to solve, you're going to have to add 3/4 to the other side. So x is going to equal positive 3/4. And in this case, you're going to subtract 3/4 to the other side. So you're going to get negative 3/4. You actually have two solutions. X equals positive 3/4 and x equals negative 3/4. And the only one of those options that is given in the solutions here is C. So our answer is C. A, B, and D are not options. Alrighty, so now you will try this last example here. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class, and thanks for watching.